Oh my god, guys,
Oh,
run!
Jiro.
There's someone trying to kill us!
Rio, where's my McDo? This is very scary. Oh no guys, we have been backed into a corner. I think showing our abs to this guy won't get him to go away. Oh no.
Hey there, little children. I will not kill you if you teach me about arithmetic and geometric sequences and series.
Okay.
Yeah, me, James, and Jiro will explain about it.
Hey guys, so the first thing we need to know is what is an arithmetic and geometric sequence. Then learn about their differences and later on show you some examples. So, what is an arithmetic sequence? An arithmetic sequence is a sequence of numbers such that the difference between the consecutive terms is constant, meaning every time the number of terms goes higher, it will constantly be added or subtracted by a common difference. Meanwhile, a geometric sequence is a sequence that exponentially changes for each term, meaning every time the number of terms goes higher, it will constantly be divided or multiplied by a common ratio. Alright, so if you still don't understand the differences, these examples might help you grasp the concept a little easier. This is an arithmetic sequence. As you can see, it is constantly being added by 2. 2 plus 2 is 4, 4 plus 2 is 6, and so on. The number that is constantly being added each term is called the common difference, and it can be easily found by simply using this formula, which can be substituted to 4 minus 2 and will equal to 2. This is a geometric sequence. As you can see, it is constantly multiplied by 4. 4 times 4 is 16, and 16 times 4 is 64, and so on. The number that is constantly being multiplied to each term is called the common ratio, which can be found using this formula, which can be substituted to 16 divided by 4 and will equal to 4. Before we head straight to finding the formulas on how I created the sequences, let's talk about the two ways of making sequences. It's either recursive or explicit. A recursive formula is used to find terms only if the previous term is given. It is usually slower compared to explicit formula. Meanwhile, the explicit formula is used for finding any terms in a sequence without requiring the previous term. Okay, now let's move on to the recursive and explicit formulas of arithmetic and geometric sequences. As you can see, this is the recursive formula. Let's say that we are finding the sixth term from this sequence. First, we have to find the value of the previous term, which is 10, according to what is given. Then, we have to find the common difference, which is 4 minus 2, which also equals 2. Now, if we substitute these values to the formula, it will turn out to be 12. Now that we are using the explicit formula, we don't have to be concerned about having the previous term since it won't be needed in the formula. Let's say that we are finding the 10th term from this sequence. First, we have to get the first term, which is 2. Then, find the common difference, which is 2. Following the formula, we will get 2 plus 9 times 2 equals 20. Next, this is the recursive formula for the geometric sequence. Let's say we are finding the fifth term from this sequence. First, we have to find the value of the previous term, which is 256. Then, we find the common ratio, which is 16 divided by 4, which equals to 4. Following the formula, we have to multiply the common ratio to the previous term to get the next term, which is 256 times 4, and this equals to 1024. Lastly, This is the explicit formula for the geometric sequence. Let's say we are finding the 7th term. First, we have to find the first term, which is 4, and the common ratio, which is 4. Following the formula, we will get 4 times 4 to the power of 6, which equals to 6,384.
So, for number 3, I was asked to show the formulas for the geometric series of the created sequence. So here are the given for the arithmetic series. So, for arithmetic series, I was asked to find the sum of the first 10 terms using the formula S sub n is equal to n over 2 times a plus n minus 1 multiplied by d, with a being the first term of the sequence, which is 2, n being the term you're looking for, which is 10, and d being the common difference of the terms in the sequence, which is 2. So if we substitute the values of our sequence to the formula, this will be the result. S sub 10 is equal to 10 divided by 2 multiplied by 2 times 2 plus 10 minus 1 multiplied by d, which in simplified form is S sub 10 is equal to 5 multiplied by 4 plus 9 times 2, which if simplified another time is S sub 10 is equal to 5 multiplied by 4 plus 18, which if simplified another time is S sub 10 is equal to 5 times 22, which if simplified another time is S sub 10 is equal to 110. So the sum of the first 10 terms of 2, 4, 6, 8, and so on is 110. So for the geometric series, I was also asked to find the sum of the first 10 terms of the sequence. Here is the formula. S sub n is equal to a sub 1 times 1 minus r to the power of n over 1 minus r, with a sub 1 being the first term of the geometric sequence, which is 4, n being the term you're looking for, which is 10, and r being the common ratio of the terms in the sequence, which is 4. So if we substitute the values of our sequence to the formula, this will be the result. S sub 10 is equal to 4 parentheses 1 minus 4 to the power of 10 over 1 minus 4, which in simplified form is S sub 10 is equal to 4 parentheses 1 minus 1,048,575 over negative 3, which if simplified another time is S sub 10 is equal to 4 parentheses negative 1,048,574 over negative 3, which if simplified another time is S sub 10 is equal to 4 times 349,525, which if multiplied together is equal to 1,398,100, which is the sum of the first 10 terms of the geometric sequence.
So we are finding S sub 10 for the series 3, negative 6, 12, negative 4, and continuously, yes, thingy, whose common ratio is negative 2.
朋友是一个坚韧不拔的纪录片，在